Yes,
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 good evening.
hearing you.
Okay, great. Okay, this is trainer Rahul. So, so yesterday we discussed certain basic topics. So, what are the topics that's involved in our certification, and what is the syllabus? We discussed about them. So today we're going to discuss about some protocols. Yesterday, if you remember, I told you that the protocols were made so that the routers of every company or the routers that were laid in the networks could exchange the information. What information? Basically, the routing information. What all the networks the router knows, it has to exchanged it has to be exchanged with the neighboring routers. Only then the network is formed. Only then the neighboring network or router will know how to reach a particular destination, right? So, for example, let's consider a router. Okay. So, you have one dot network connected to this router, two dot network connected to this router, three and five, for example. Okay. And these two routers are connected. There is a switch here, a PC here. Okay. So when a PC wants to get to 5 dot network, it obviously goes to this router because this R2 will be mentioned as the default gateway on this PC. Okay. So obviously the data traffic goes here. Now, what does R2 do if it doesn't know the information where is the 5 dot network? There came in the necessity that the routers actually have to exchange information between each other. Also, I told you yesterday that before the administrator, what they used to do, they used to write this routing information manually. Oh, go to R2 if you want to reach 5 dot network. Okay, let's say this is 20.1.1.1 and this is 21.1.2. Okay, if you want to reach 5 dot network, then go to 21.1.1. Okay, this is how they used to write the routing information manually on R2. But if there is one router in an organization, that's fine. But what if there are many routers, abundance of routers? Say let's say we have 30 routers. An administrator feels it's a very hard task for the administrators to go to all the routers and write this routing information. So there came the invention of dynamic routing protocols. What are the dynamic protocols, routing protocols that we know? I know EIGRP, I know RIP, I know OSPF, ISIS. These are the, and before EIGRP, there was something known as IGRP. These are the routing protocols, dynamic routing protocols that actually helped us without any intervention of the administrator. They helped us to exchange the routing information dynamically, automatically, without any intervention of administrators. How they used to do? Let's see that. Let's study that through our slides. First of all, let's actually get introduced to some of the basic terms of EIGRP. Now, what does EIGRP say? It's a Cisco proprietary protocol. So it was actually discovered by Cisco. It was actually, Cisco actually found the EIGRP protocol. So it's known as Cisco proprietary protocol. It used to work only on Cisco devices. Only on Cisco devices we used to configure this EIGRP. It is known as distance vector protocol or a hybrid protocol. Distance vector. What do you mean by distance vector? Vector is nothing but your direction. When you say vector, it means direction. Either this direction or this direction. It calculates the distance. If you have a router over here, it calculates the distance in both the directions. Let me take a new one, new sheet. You have routers here, 3 routers connected. If you want to reach R3 from R1, EIGRP calculates the distance from both the sides. Okay, whichever is having the less cost or the less unit, less amount of, or the best path, let's call it as a best path, that will be chosen as the best route. So distance, this is the distance, this is another, I'm sorry, this is one direction, this is another direction. That is known as vector. Distance, it calculates on both the ends, on both the directions. That is why it is known as distance vector protocol. Okay. Also known as hybrid protocol. The third, it is a classless routing protocol in the sense it does not worry about the classes and the default subnet masks. Okay. The metrics that are used in EIGRP, metrics in the sense whenever you calculate something. So when you are weighing something, the unit is kgs, right? Similarly, the metrics that are used for this EIGRP protocol is bandwidth, load, reliability, MTU, and delay. Okay, these are the factors: bandwidth, load, delay, MTU, and reliability. These are the factors that are taken into consideration while calculating the best path. You might ask me how it is calculated using these factors. Now, when you have to reach any of the routers, it calculates the bandwidth of this link, the delay on this link. It calculates the MTU in this direction, reliability, load. Okay. Same goes with this direction as well. It calculates all these factors on both the directions, whichever is the best or whichever is less. These factors, having these factors, the formula is calculated, whichever is the best path in the sense less, having less cost, that will be taken as a best route. Okay. The administrative distance of EIGRP is 90. So there is no other workaround for administrative distance. This is one such thing that you have to remember about every protocol. Okay. For example, administrative distance of EIGRP is 90. Let's say BGP internal is 200, external is 20. You have to remember this. So there is no workaround for administrative distances. Okay, this is one such factor that you have to always keep in mind. And also, same goes with this one, the multicast address. What is the multicast address? Why it is used? So EIGRP protocol actually uses a multicast address of 224.0.0.10. For what? Let's say you have two routers. You have two routers, R1 and R2. Okay. Let me take a screenshot of this. Okay, let's say we have R1 and R2. Hope it is not dirty. Hope everyone can see this. Now, R1 sends hello message to 224.0.0.10 because EIGRP protocol is configured in such a way that it uses multicast address of 224.0.0.10. All the routers which are configured with EIGRP send messages to this particular multicast address. Okay, we already know that class A address, class B address, there are 5 class of address. Class D is selected for multicast. We already know that, or we can discuss in our training classes further. So class D is reserved for multicast, and one of the subnet that is used in class D for multicast address for EIGRP is 224.0.0.10. All the routers configured with EIGRP send their hello packets to 224.0.0.10. Similarly, the same goes with R2. R2 also sends its hello to 224.0.0.10, saying that I am R2, my hello interval and my dead interval is so and so, so on. You will have lot of update on that 224.0.0.10. For example, you can find it here. First, a router sends a hello. Then R1 also sends a hello. They come to know that they both are next to each other. They send a hello. Then this is a unicast hello coming in from R2 to R1. R1 will update its routing table to R2. R2 will acknowledge the routing table received by R1 and then update its routing table to R1. R1, once it receives the routing table, acknowledges R2 with a ACK message. Okay, that is how the neighborship is formed. So, neighborship, please excuse my handwriting. Neighborship and adjacency. These are the common words used in the networking domain. You can also say that two routers are neighbors of each other. They have established neighborship between each other. Also, you can say they have formed adjacencies. Okay. Now, once these routers, so let me repeat it again. The router R1 sends a hello packet to R2 on 224.0.0.10. Once this receives the hello, this sends a unicast hello. It will not be a multicast then. Okay. It will send a unicast hello since it knows R1. It will also send its IP address since it knows. It sends a unicast hello. Then they will, once the hellos are exchanged, then they will go ahead and exchange the routing table between each other. Once the routing table are exchanged between each other, we we can say that they have formed adjacencies or they have formed neighborship with each other. That is the process of neighborship in an EIGRP protocol. And it happens automatically. You do not have to. Remember, I told you that earlier, administrator would manually go connect a console cable or log in remotely to this, you know, to this router and then say command IP route 5.network. If you want to reach 5.network, go to 20.112. He used to manually type in this command on R2. That is the static route. Those are known as static routes. But once these updates are exchanged between R1 and R2, these are known as dynamic routes. The routes exchanged between R1 and R2 dynamically are known as dynamic routes. We didn't do anything here. We just configured EIGRP in this router. We just configured EIGRP on this router. Since they both are EIGRP, they have a tendency to, once they have been configured with EIGRP, they have a tendency to send their hello packets to 224.0.0.10. That is how they identify each other. Okay. That is about the neighborship that we have in EIGRP. Now let's talk about the tables in EIGRP. EIGRP has three main tables. Also, while you're troubleshooting, you got to make sure that you know these three tables well. Once you know these three tables well, then you will be good at troubleshooting as well. Okay. So basically, we need to know the three tables very well. Now, what is neighbor table? I just told you that two routers become neighbors of each other. How? Through this 224.0.0.10, the multicast address, they exchange hellos, then they exchanged update. Update in the sense updating the routing table to each other. That is how they become neighbors. How do you see who is the neighbor of R1? There is a command known as show IP EIGRP neighbors. Similarly, if you go to R2 and say show IP EIGRP neighbors, it will show who are all the neighbors of R2. Okay. Similarly, you have a topology table. Topology table is one such table where you find all the routes. Okay. All the routes. Routing table, there is no space for all the routes. Routing table only stores those routes which are the best routes. Okay, only the best routes are stored in routing table. Now, while looking at it, let's actually go and do a small lab on EIGRP just to have a practical knowledge. Let's go to, yeah, let me close this lab. Okay. So this is the topology that I have. I have four routers. Let me actually introduce you the topology first of all that I have. I have four routers, R1, R2, R3, R4. What is the address connecting R1 and R2? It is 1.1.1.1 and 1.1.1.2. Okay. What is the IP address connecting R2 and R3? On the R2 side, we have 2.2.2.1, 2.2.2.2. Similarly, R3 to R4, 3331, 3332, R42, R1, 4441, 4442. Okay. Now, let me start all the devices. Let's get into the router. Okay. I have R1 started. I have started R1. If you all can see my screen, that's good. Okay, I'll show you what is on R1. Okay, enable show IP interface brief. This is the command I use to check what IP addresses have been assigned to what interface. Okay, I know it's something basic. I know everybody knows about it, but there might be some people who are not aware of it. So I'm just stressing on everything. So please do not mind. Show IP address, show IP interface brief is the command that I use to check what interface. R1 has two interfaces, S1 bar 0, S1 bar 1. S1 bar 0 and S1 bar 1. They both are administratively down and they do not have any IP address assigned to them. Okay, now let's configure this one. I could have done this configuration earlier and kept it ready for you, but if I do it in front of you, hopefully that actually stays in your mind. So that's the idea behind it. So let's go ahead and configure it. Configure terminal. Okay, this is how you enter the configuration mode on a router. Now, what's the interface that I have to configure first? First, let me take this interface, S1 bar 0. Okay, how do you go to that interface? Interface S1 bar 0. Okay, you are inside the interface now. What do you want to do? I want to assign an IP address. How do you assign an IP address? IP address 1.1.1.1. Okay, this is how you assign the IP address. And it's not about only the IP address, you have to assign the subnet mask as well. I am taking a C class subnet mask. We'll discuss about the subnet mask and everything in our future classes. And also I have to give a no shutdown because you remember it was administratively down. Administratively down in the sense the port was down, it was shut down. So it's our responsibility wherever you see an interface which you want it to be active, you have to give a command known as no shutdown for that particular interface to come up. Okay. You can see the message now. Interface S1 bar 0, change state to up. Okay. Line protocol on interface S1 bar 0, change state to up. Okay. Let's do one more thing here. Now let's repeat the same command. Show IP interface brief. Now you can see S1 bar 0 has been assigned an IP address of 1111 and the status is up and it's not administratively down. Even the line protocol has been up. Okay, simple. Let's do the same thing for the other interface S1 bar 1 that you see here. Okay, interface S1 bar 1. I have entered the configuration mode. Now I am entering the interface that I want. IP address 4.4.4.2, 255.255.255.0, no shut. Okay. Hope this is not fast and you got it. Okay. Similarly, once it comes up, you get a message. Okay. This is how you make sure that, okay, the interface has been up. Then you have a command show IP interface brief. On R1 side, you see that S1 bar 0. We have two interfaces, S1 bar 0 and 1 bar 1. both have been enabled. Both are up. Okay. Manually up. And it's not administratively down. So that's good. Now let's go to next router, R2. Similarly, we need to configure this as well, the same way that we configured R1. Okay. Okay, enable show IP interface brief. First of all, I need to check which are the interfaces available and if they are assigned with any IP address. None of them have been assigned any IP address. So all good. We are configuring it afresh. Okay. Now, how do you start configuring it? Enter the configuration mode. How do you enter the configuration mode? Say configure terminal. And then what is the first interface that you have on R2? S1 bar 0, right? S1 bar 0. So interface S1 bar 0. What's the IP address that I have assigned to it? 1112. Okay. IP address 1.1.1.2, 255.255.255.0, and no shutdown. Okay. Did I receive the message? Yeah, I received the message. So let's go to the next interface. 2221 interface S1 bar 1. I'm already in the configuration mode. So I'll just give the interface name. Okay, interface S1 bar 1. It will immediately go to that particular interface. IP address 2.2.2.1, 255.255.255.0. No shut. Have I received any message? Line protocol is up. Okay. How do we verify it now? Simple command show IP interface brief to verify what are the interfaces we have and which are up, which are down. So 1 bar 0, 1 bar 1. What's the status? 1 bar 0 and 1 bar 1. They're up, they're not administratively down, and they've been assigned with the right IP address that I wanted. Okay. Let's go to R3. R3. What? Let me actually reduce the size of it. I think I can't. Okay. I hope you can see this. So it takes a bit of time. Yep. Okay. Enable. Now I have two interfaces, S1 bar 0 on R3 and S1 bar 1 on R3. Okay. So if I have to assign IP address to those interfaces, first of all, I have to enter the configuration mode. So I'm doing configure, giving the command configure terminal interface S1 bar 0. S1 bar 0, the first interface, IP address 2.2.2.2, 255.255.255.0. I'm sorry, you're not able to see it fully. Okay, this is how no shut. Okay, done. The first interface is done. I got a message also. I just waited for it and I got the message saying that the line protocol is up, the link is up. Okay, the next interface is S1 bar 1, IP address 3.3.3.1, 255.255.255.0. No shut. Waiting for the line protocol up message, link up message. Okay, received. Now do a show IP interface brief, show IP interface brief to verify what are the interfaces available and to check if they are not administratively down. So both are up, both the interfaces are up, and the assigned IP address you can see 2222 and 3331. Looks good. Let's go to the next router. Nope. It takes a bit of time. All right. Enable Enter the configuration mode by typing configuration terminal, configure terminal, and we have two interfaces again, S1 bar 0 and 1 bar 1. Interfaces S1 bar 0. The first interface, IP address 3.3.3.2. Am I on the right? S1 bar 0 is 3332. Okay. No shut. Okay. Interface S1 bar 1. IP address 4.4.4.1. 255.255.255.0. No shut. Okay. Link up down message. Show IP interface brief. Okay, there you go. Manually up. So right now, what I have is forget about the other things, the loopbacks, the 10 dot network here, the loopbacks here, the loopbacks here, the 30 dot network. I just have this WAN. So these are the WAN links. Why they are called as WAN links? Because a router is connecting to another router. So they are WAN links. I have configured only these WAN links with the IP address 1111.1112.2221.2222 in a similar way. Okay. I've configured only these WAN links, not any IP address, not on any other interfaces. Okay. Now, now our goal is establishing EIGRP neighborship between R1, R2, R3, R4. Now, when you go to R1, and if you want to verify the routing table of R1, you want to verify the routing table of R1, what do? What is the command? Show IP route. Enter. It'll only show you whatever is connected to it. How do you know whatever is connected? Because it is clearly telling you, see, only connected routes. And you can see here, the code C indicates that it is connected. When you check R1, it is showing that 1.1.1.0 network is directly connected, and where it is connected to serial 1 bar 0. Obviously, we can see it, right? That is how we have configured it. And 4440 network is directly connected and it's on serial 1 bar 1. Okay. So all the routing table, if you check on other routers as well, it will only show you whatever is connected to it. Is R2 showing 1111 or maybe 4442? R2 is not showing you 4442. It does not know. So try to ping 4.4.4.2 from R2. 3 blank pings. Done. Success rate is 0, 0%, 0 bar 5. It tried 5 times. R2 was not able to see where 4.4.4.2 is. Why? Because if you check the routing table of R2, it does not have 4.4.4.2. So when a traffic comes here, when a data packet enters this R2, where is R2? It is here. Okay. When a data packet enters this R2, and it has the destination IP address of 4.4.4.2, R2 checks its routing table. Do I have 4. Network in my routing table? No. Obviously, the traffic or the packet will be dropped because R2 doesn't know where to forward it, right? Similarly, when you go to R3, R3 only has connected routes, that is 2. Network connected on this side of the interface, 3. Network connected on this interface. Now, R2 will be able to ping 2.2.2.1. I know it has 2.2.2.2, but it will be able to ping 2.2.2.1. Let's see. It is because it knows that 2. Network is directly connected on this interface S1 bar 0, right? From the routing table, when you say ping 2221, it checks its routing table. Do I have 2221? Yes. Which interface should I send it to? S1 bar 0. It will send it through S1 bar 0. The 2221 response it's back because it also has 2221 on its end. It can see 2 network. If you get anything for 2 network, send it on S1 bar 1. It will send it back on S1 bar 1. So they are able to respond. Now let's ping 1.1.1.2 from where? R3. This is R3. This is R3. I'm pinging 1.1.1.2, which is here. Okay, hope you're able to see it. 1.1.1.2. Let's see what happens. It's not able to ping. So the minute I say success rate is 0%, the minute I say 1.1.1.2, ping 1.1.1.2, first of all, the router checks its routing table. Do I have one network or no? The first thing that it does is checks its routing table. When there is no one dot network, obviously the packet is dropped. Similarly with show IP route. Okay, only connected networks are there. Now, let's take some time in configuring EIGRP. Let's go to R1. How do you configure EIGRP? Now I have R1 and R2. Okay, R1 and R2. I have to establish EIGRP between these two first. Let's configure EIGRP on this router R1 first of all. Okay. Now how do you configure it? Obviously, all the configurations are done on the configure terminal. I mean, on the configuration mode. Okay. On the configuration mode itself, you do all the configuration. So first of all, I have to enter the configuration terminal. Okay. Once I enter router EIGRP, once you type EIGRP and give a question mark, it asks you for the autonomous system number. You can select any autonomous system number that you want. Let me select one. Router EIGRP1. Now, you have just started the EIGRP process, but you haven't let the router know, which interfaces are involved in this EIGRP. Okay, or which networks are involved in this EIGRP. You haven't told that. Okay, to tell that, if you just hit a question mark, I'm sorry. Okay, you can just type network. If you want to involve this particular interface S1 bar 0 in EIGRP, you can type that particular network 1.1.1.1 question mark wildcard bits. Now, what is the wildcard bits? Sorry if you know these concepts, but I have to explain it again for people, for everyone on this group. So 255.255.255.255 global subnet mask. Okay. And what is the subnet mask of this one? Of 1.1.1.1? We gave it as 255.255.255.0, right? So it is 255.255.255.0. When you subtract from global subnet mask from the actual subnet mask of an IP address, you get the wildcard bits. Okay, simple, right? So this is the global subnet mask. This is the subnet mask of that particular IP address. There you get the wildcard bits. Now, what is the wildcard bits? So wildcard bits of 1.1.1.1? It is 0.0.0.255. Simple. And question mark, it says just enter it. Enter. Now again, you have to enter another network. You have to involve, now you have to involve this as well, this interface as well. Which interface is it? S1 bar 1. So type in that network as well. Network 4.4.4.2. What is the wildcard bits for it? Same, because the subnet mask for 4.4.4.2 is 255, 255, 255, 0. 255, 255, 255, 0. When it is subtracted from this global subnet mask, you get the same wildcard bits. So it is 0, 0, 0, 255. Okay. Now you have enabled two interfaces on EIGRP. Now what happens when you enable these two interfaces? EIGRP, this router will start sending hello packets on this interface. Will it send towards R2? It will send towards the multicast address 224.0.0.10. Okay. But this is not able to see it because this is not enabled with EIGRP yet. R2 is not enabled with EIGRP yet. Let's go ahead and enable that particular interface S1 bar 0. Okay. Before that, you have enabled these two interfaces in EIGRP. Let's check if we have any neighbors. Show IP EIGRP neighbors. No. IP EIGRP neighbors for process 1. Nothing populated under this. Okay. There is nothing under this. So you do not have neighbors yet. Let's go to R2. I have to configure EIGRP. Get into the configuration mode. Type in the command router EIGRP 1. Autonomous system number 1. Remember that we have to have the same autonomous system number, whatever we use. Inside the same network, we have to use the same autonomous system number. Okay. Now you have to enable this interface. Somebody has asked a doubt saying that update packet is unicast or multicast. It is always unicast. Okay. The update packet is unicast. It's not multicast. Okay. Hope that answers your question. So let's enable this particular interface, which is S1 bar 0. Okay. How to enable that? Network. What is the IP address on particular interface? 1.1.1.2. 2. Wildcard bit 000 255. Enter. Now once you enter it, see there, you see that this was already sending hello packets, but it was not receiving it. Now once we enabled that particular interface in EIGRP, both were able to see each other. So the result is they ended up in being neighbor of each other. Neighbor, let me show you the full message. Neighbor is up. Neighbor is up. New adjacency. If you can see this message, neighbor 1.1.1.1. It has figured out that my new neighbor is 1.1.1.1, which is here. Okay. Now let's enable EIGRP on this interface as well. How do you enable EIGRP on that interface? Simple. Add that network as well. Network 2.2.2.1. Wildcard bit 000 255. Enter. Okay. Let's go to R3. Configure terminal. Router EIGRP. Before that, we did not check the adjacency here. Okay. Let me check the adjacency. How to check the neighbor table? Simple. Show IP EIGRP neighbors. Now, you see that on R2, when I gave who is your neighbor, to check who is the neighbor of R2, I gave a command known as show IP EIGRP neighbors. What did R2 reply? He said, I have an address 1.1.1.1. Who is my neighbor? How do you know he is the neighbor? Because the uptime of that neighbor is 1 minute and 25 seconds. Okay. He is my neighbor. And what is the interface through which we have formed neighborship? It is 1 bar 0. 1 bar 0. Because it is connecting to 1.1.1.1 on 1 bar 0. And the whole time, I'll come to hold time, and you know, hello interval, dead interval, hold interval. Okay. The uptime, as I told you, the neighborship, since the neighborship has now, if I bring down that particular interface, if I bring down this interface goes down, neighborship goes down. If I bring it back up, there will be a new uptime. Okay. I'll talk about this. We'll talk about this in the next sessions. This is round trip timer. I'll talk about this. And this is the sequence number through which the adjacency has happened. Okay. Let's go to R1. In R1 also, you have got that message saying that I have a new neighbor, and the neighbor, his name is 1.1.1.2 and through serial 1 bar 0. Okay. 1.1.1.2 is my neighbor. Okay. Really? Let's check neighbor table. This is the neighbor table. My neighbor is 1.1.1.2 and the interface through which we have formed neighborship is 1 bar 0. Okay. Router EIGRP1. Let's do the same on R3. Enable the interface. Are you able to see it? I think I'll drag it this side. Let me actually shorten it up. Okay. Network 2.2.2.2. Wildcard bits 000 255. Enter. Okay. Neighbor adjacency is up. Network 3.3.3.1. 000 255. Enter. Now R2 should also be its neighbor. Why? Because R2 is already, this network 2221 is already enabled. Okay. So let's check show IP EIGRP neighbor. Show, how do you check the neighbor table? Show IP EIGRP neighbors. I'm just keeping on repeating it so that it stays in your mind. Don't mind. So neighbor is 2221. This is the interface through which the neighborship is formed. Okay. Let's go to router 4. Router 4. What happened? Show IP interface brief. Everything good? Yep. All good. So configure terminal router EIGRP1 network 3.3.3.2 000 255. Okay. Adjacency established. Network 4.4.4.1 000 255. There you go. We've established neighborship on all the routers. Now, let's talk about, without seeing this, let's actually assume, okay, without going into this router and querying this router, who is your neighbor, we'll actually try to guess it. Now for R1, you have enabled this interface in EIGRP, you have enabled this network on this interface on EIGRP. Similarly, R2 also you have enabled both of them. In R4, both of them. R3, both sides. Okay. So for R1, who are all the neighbors? One is this side, that is 1.1.1.2. The other one is this side, 4.4.4.1. So there has to be two neighbors for R1. Let's verify that. Go to R1. show IP EIGRP neighbors. As I said, as we discussed, 4.4.4.1 is the first neighbor, right? This is my first neighbor. 1.1.1.2 is the second neighbor. So you can see the sequence in which the neighborship happened. 1.1.1.2 is 0 and 4441 is 1 because first neighborship was this one which was established, right? That is why it is 0. 4441 was established later. So the order in which the neighborship was established is actually denoted by 0 and 1 here. Okay. Similarly, in R2, you have two neighbors. One is 1.1.1.1. The second one is 2.2.2.2, right? Same goes with it as well. For R3, the neighbor is 2221 and the other side it has 3332. Let's verify that. As, as we discussed, it is 2221 and 3332, right? 2221 because it was formed first and then 3332 second. For R4, who are the neighbors? Oh, show IP EIGRP neighbors. For R4, one is 3331. Second one is 4442. Let's verify. Yeah, 4442 and 3331. This is how we established EIGRP neighborship. As you can see, I did not go into this router and enter any manual command, right? I did not enter any manual command saying that for to reach 2221 on router 1, I was able to only ping to 1.1.1.2 from router 1. I was not able to ping 2.2.2.1, right? Let's see. Now let's try to ping 2.2.2.1 from router 1. I'm able to ping it. Surprising. Now let's try to ping 2222. Ping 2.2.2.2. Oh, sorry about that. I'm responding to 2.2.2.2 as well from R1. Okay. Now let's try 3331. Done. Successful. What's happening now? Once they establish neighborship, why am I able to ping all the routers? Before I was not able to, right? The only difference, you can see it here. Once this is the routing table that I'm showing you by entering the command show IP route. Once the routers become neighbors of each other, they exchange information. Okay. R2 says my connected routes are 1 dot network and 2 dot network. See here, 1 dot network, 1 dot network, and 2 dot network via 1.1.1.2. So if I ask R1, from whom did you learn 2 dot network? Obviously from my neighbor. It recognizes neighbor R2 as 1.1.1.2, right? Same thing is written here. 2 dot network, I know it via, I know him via 1.1.1.2, right? How do you know 3 dot network? Via this neighbor 4441. He is one of my neighbors. He actually told me that he knows something like 3332. So he forwarded the same information to me once we became the neighbors, right? 3 dot network, I know it via 4441. Simple, right? And also, not only that, let's see. This is the routing table that we have. Let's see the topology table. So we actually discussed three tables, right? Neighbor table. Neighbor table contains directly connected neighbors, list of directly connected neighbors. We saw that. Okay, who are the directly connected neighbors for R1, R2, and R4, right? So now you can actually make out while we did practical, while we did it practically, now you're able to identify it clearly that okay, neighbor table is the list of directly connected neighbors. Why? Because when I did a show IPEAGRP neighbors, it showed me which are directly connected neighbors 4441 and 1112, right? List of directly connected neighbors. This table is stored in RAM. You have to always remember this, that inside the RAM of R1, inside the RAM of R1, this neighbor table is stored. Neighbors are formed by sending hello packets to multicast address 224.0010. I already told you that. Okay. And how do you see the neighbor table? By the command show IPEIGRP neighbors. Simple. Topology table, I'll come to that. Routing table. Routing table contains the best routes to the destination as calculated by the router. Now, as you can see here, show IP route. This is the command to see the routing table. In the routing table, what do you have? To reach the 2-dot network, first of all, or let's do a show IP route EIGRP. Only let's filter EIGRP routes. Only routes that I've got by EIGRP. How do you identify EIGRP routes? Because it is written D. Here it was D and C as well. It was showing me the EIGRP routes and the directly connected routes also, right? If I want only the routes with EIGRP, then I have to say show IP route EIGRP because the code D stands for EIGRP. Okay. Now, how do I know 2-dot network? 1.1.1.2. Okay. That is the best route because the distance that you see, this is the administrative distance. Forget about it. This is the distance that I have for this network 2.2.2.1. Okay. And for 3-dot network, 3-dot network is here. This is the distance that I have. This is the best distance. Okay. It calculates the distance as well. Now, let's see. We'll talk about this dual algorithm and all that. Let's see the topology table. Do not be confused. If you have any confusion, you can ask me. Topology table show IP EIGRP topology. Now, when I click on topology, you can see that 1-dot network 1.1.1.0, forget about it. It is directly connected. Let's talk about 2-dot network first. 2-dot network, I know it via 1.1.1.2 and the distance is so and so. There are two distances. One is advertised by the neighbor and the actual distance calculated from that particular router. We'll talk about it in the future classes. And this is the distance for 3-dot network. Okay. This is the distance for 4-dot network. Now, when you have equal distances in the sense from here to here, same distance, from here to here, same distance. Let's check out R2, show IP EIGRP topology. Okay, same thing. The distance calculated. The difference between the routing table and the topology table. What is it? So now let's assume I am in R1. If I have a loop back on R3, if I have a loop back on R3, which is nothing but 13001. Let's assume 13001. The distance from R1 to 13001 would be the same from this way also, right? Because it is a loop back. This way also it is same distance. This way also it is same distance. Okay. Or you can reach, in other words, you can reach 13001 from this way and this way also. So both the ways, both the routes will be in topology table. But in the routing table, when you do a show IP route, the route which is having the least cost or least metric, only that will be installed in the routing table. That is the major difference between the routing table and the topology table. Okay. As you can see here, routing table contains the best routes to the destination. Only the best routes are installed in the routing table. And EIGRP, I told you, it calculates the metric. Okay, it calculates the metric, it calculates the path. What is the value of that path? It calculates it. How does it calculate it? With the help of dual algorithm. Dual algorithm is also known as diffusion update algorithm. That is why it is known as dual algorithm. Okay. In this scenario, R1 to 13001 has a distance of 50. R1 via R4 to this R3 has a cost of 60. Both will be installed in topology table, but only with the cost of 50 will be installed in the routing table. Okay. The best route is known as a successor, the one with small units, the one with lowest metric, that is known as successor. The second one is known as feasible successor, and that will be only present in the topology table. The second best route will only be in the topology table. It will not come into the routing table. The routing table only has the best routes. So today that we learned, just to revise, the things that we learned are about EIGRP is it's a dynamic routing protocol. You saw how dynamically it was able to exchange the routing table between one router to another. Okay. And also you learned about the three tables in that particular protocol. What are the three tables? Neighboring table, neighbor table. It contains the list of neighbors. Topology table contains all the routes to any particular destination, all possible routes to that particular destination. But routing table contains only best routes to the destination. Okay. Now, EIGRP metric. What are the metric that we use in EIGRP? I told you it is bandwidth, load, delay, MTU, reliability. Okay. Let's talk about some metrics. First one is the bandwidth. What is the bandwidth? Bandwidth is actually the amount of traffic that you can send on a link. Okay. If you have a link, the bandwidth is the amount of traffic or the space that you have to send on this link. Okay. That is known as bandwidth. And always EIGRP keeps 50% of the bandwidth for updates, incremental updates. I'll tell you about this. Normally, when there is a serial link, how do you identify a serial link? When you have a S1 bar 0 interface, that is a serial link. When you have Ethernet interface, that is a Ethernet link. When you have FA 1 bar 0, that is a fast Ethernet link. When you have GI 0 bar 1, that is a gigabit Ethernet link. The bandwidth of this, these are the default bandwidth of the serial link. Now, since I have serial link over here, the bandwidth of this serial links will be 1544 kbps. How do you know? Really? You want to see? If you want confirm it, actually just play with the router. So show interface S1 bar 0. Just do that. And once you do that, you always have something known as bandwidth here populated. Okay. Bandwidth of this serial link will always be 1544 kilobits. That is the default bandwidth on the serial links. If you take a Ethernet link, 10 Mbps is the default bandwidth. Fast Ethernet links has 100 Mbps bandwidth. Gigabit Ethernet links has similarly 1000 Mbps of bandwidth. Okay, that is the bandwidth, default bandwidth levels of the interfaces. Bandwidth can also be changed on the interface level, but it is not recommended to change the bandwidth, because once you change the bandwidth, the EIGRP again runs a algorithm to calculate the best route, and it might affect other side of your calculations. EIGRP finding the best route in a company. So it is not recommended to change the bandwidth on the interfaces, but to keep it to default. What is a delay? Delay is the packet travel to and fro from the destination. That is, packet is traveling to R2 to and fro. What is the time taken for the packet to travel and to come back to the same router? That is known as delay for the response time. Okay, to and fro. That is known as delay. Like how bandwidth we have default bandwidth of Ethernet links, serial links. Similarly, we have default delay of serial interfaces, which is 20,000 microseconds. Yes, is it so? You can see it here. Delay is 20,000 microseconds. That is the default bandwidth of serial links. Similarly, default delay of Ethernet link is 200 microseconds, of fast Ethernet 100, gigabit is 10 microseconds, and so on. Delay can also be changed, but delay, it's not recommended, and it is multiplied by 10 or interface level. I'll tell you about that, don't worry. So next metric is load. Load is the amount of traffic moving on the link. So you have a link, what is the amount of traffic that is moving on the link? Okay, values are 1 to 255. How do you know? It is mentioned here. Load, transmission load 1 out of 255, receive load 1 out of 255. 255 represents more load, 1 represents very less load. Okay, transmitting load, receive load. Load cannot be changed on the interface level because you don't decide the load. The network, the amount of traffic being sent on the link, that decides what the load is. Okay, next, maximum transmission unit. We all know that the maximum transmission unit of Ethernet is 1500 bytes. That is the maximum possible packet size that we can send out of an interface, right? That is known as MTU. So that is about the EIGRP protocol that we have. Further moving on, we have dual terminology, feasible distance, advertised distance. We can discuss these in our regular classes, on the training classes. Regarding EIGRP, there are many concepts that are actually used for, problem solving or enterprise troubleshooting purpose. So once you know about the tables, how EIGRP reacts, and what are the things that are used to calculate the values, and how EIGRP can be manipulated, then the troubleshooting part in the enterprise network becomes easier. Okay, so having said that, I would like to ask you if you guys have any doubts on today's session. Are you all good? Okay, I take that as no doubts. Okay, there are 3 chats. Okay, all right. If you can also message me if you're not able to talk, you can also message me. So this is about the topics that we had for today. So we discussed about EIGRP protocol, how dynamic protocols are useful and how they reduce the load of our administrator, what are the 3 tables that we have, and how we can, I also configured EIGRP on 4 routers. I showed you how they establish neighborship between each other, and how to check you know uh, the routing table on all the routers, how to make them pingable. Once they exchange information, they become pingable. So we evidenced all that today. So that's what I had for today. So I think that's the most of it. So if we need to continue further, we can actually, I also would like to, once again, I would also like to put this on screen. So if anybody has plans of joining the training courses, this is the WhatsApp number. Okay, so I think they've already shared it on yeah, this is my team WhatsApp number. So I'll just put it on the chat so it becomes available to you guys. Okay, this is the WhatsApp number. So if you need any further plans on training, admission pricing, so please go ahead and contact this number. Once again, if you want to see this syllabus and also the things that we discuss on the training, the things that is going to be happening on the training, this is the link for you. This is the link that you can. I don't think so. Am I putting it in the chat? This is the link. Did I put it to you guys? Yeah, I think you have the link with you. Yep. All right then. So if you guys do not have any doubts, so that's it from my end. I would like to thank each and one of you. Thank you so much for giving me time. Have a good rest of the day, and I would like to see every one of you in the training. So let's once we join, we can actually,
Hi, I have one question.
Hey
Rahul.
Ayub. Yep, go ahead, Ayub.
So it's a everyday session every day or what?
So we have, we are yet to decide. Is it going to be a weekend batch or is it going to be a weekday batch? We're yet to decide. Depends upon the, you know, how people are comfortable. So how the people who join, how they are comfortable. So for that, I think you need to get in touch with that WhatsApp number that I just gave you. So they'll actually, so depends upon, basically depends upon you, Ayub. So whenever you're interested, so majority of people, how they are interested, depends upon that.
Okay, okay, well, okay, thank you.
Thank you, Ayub. Anybody, any questions? All right. I'll take that as none. Have a good rest of the day, guys. Have a good one. Take care, everyone.